So we shall start the class. Okay. So is the screen visible?
Yes, sir. Yes, sir. It's visible.
Okay. So in this class, we will be seeing about shear force diagrams and the bending moment diagrams. Okay. So before going into the shear force diagram and the bending moment diagrams, and first we will see what is actually a bending couple, what is a twisting couple, and then we will next see about the sign convention of shear force and sign convention of bending moment diagrams. Okay. So first we will see what is a bending couple. And the twisting couple. Okay. So imagine you are having a cross section like this. Okay. This is the cross section of a member, rectangular member. Okay. So you are actually loading this cross section by a force like this. Okay. Okay. So whenever the force which is applied is actually perpendicular to the cross section, then you term the couple formed due to that as a bending couple. Okay. So here, what is the direction of the force with respect to the cross section, whether it is parallel or perpendicular?
It's parallel, sir.
Perpendicular.
Yeah, it's perpendicular actually. It's not parallel. Parallel means it will be like this. Okay.
Sir.
Yeah. So this is actually parallel to the cross section. And this is perpendicular to the cross section. Okay.
Yes, sir.
Yeah. So this perpendicular to cross section, if a couple is formed, then due to this, what you will get? You will get a bending couple or twisting couple. Anyone?
Bending.
Yeah, you will get a bending couple. And if you have the couple which is parallel to the plane of cross section, then you will have a twisting couple. Okay. So this is clear, right? When you will have a bending couple and when you will have a twisting couple, huh?
Yes, sir.
Yeah. So the next thing is like the sign convention of shear force and bending moment diagrams. Okay. So actually, what is meant by a shear force? For example, this is a bar of cross section, let's say D, a circular cross section of diameter D. So what is this actually? This is an axial load, right?
Yes, sir. Tension.
Yeah. So this, for example, if you apply a load which is perpendicular to any cross section, then this is termed as a shear load. Okay. And if you take any cross section, okay, and the sign convention for shear force will be like, for example, if you have a cross section like this, okay, and for example the clockwise direction, if you have a clockwise direction, for example, due to this uh, force, like if you have a couple which is like rotating the member in clockwise direction, then you term this as a positive shear force. Okay. So can you say whether this P is a positive shear force or a negative shear force?
Negative shear force.
Yeah, this is a negative shear force. Okay. For example, the diagram which we have drawn is like this. Okay.
So, but in many references, I have seen sometimes they use this kind of load act as a positive load, sir. Is that
Y- yeah,
vary, sir?
yeah, it can vary actually, because
Okay.
once we get set with the sign convention, actually I follow this sign convention. Okay, like clockwise means it's positive, and anti-clockwise means it's negative.
Okay, sir. Okay.
So once you are set with the particular sign convention, then you can proceed with the sign convention, and you have to stay with that sign convention for all the problems. Okay.
Okay, sir.
Yeah. So this is good. So this is a positive since clockwise. This is negative since anti-clockwise. Okay.
Okay.
Yeah. So this is the sign convention of shear force diagram. Now coming to bending moment diagram. Okay. So for bending moment diagram, for example, I have a cantilever beam like this. Okay. And I have a moment reaction like this. For example, it can be some m, okay, some value of m. So now I am taking a particular cross section and I am examining the in which direction. For example, in the left hand side, if it is like in which direction this moment is actually acting, it is clockwise or anti-clockwise?
Clockwise, sir.
Yeah,
So
clockwise.
positive.
Yeah, positive.
Clockwise.
Yeah. So in the left hand side, if it is clockwise, then it is positive. And in the right hand side, if it is anti-clockwise, then it is positive. Okay. Which means like you are getting a shape like this.
Sagging.
Yeah, sagging. So in this, what will happen to the top fiber? This is the top fiber. And for example, if I am drawing like this, and this is the bottom fiber. Okay. So in the in sagging moment, what will happen? Top fiber actually contracts and bottom fiber elongates. Okay. So
Uh,
left clockwise and right anti-clockwise means the bending moment is positive. Okay.
okay.
Yeah. So now let's proceed to the. So before proceeding to the problems, I want to say another one thing. For example, this is with respect to the orientation of the beam like this. Okay. For example, if you have a beam like this, okay, and then you are actually giving a moment like this, okay, bending moment like this or bending couple, then what you will say about the sign convention? For example, the sign convention is as like this. Okay, like if the top layer or if the back layer of or if the left layer contracts, then it is positive. Okay. So for example, in this, what you can say, see, this is actually the right side, right? And this is the left side. So in this, what happens? Which one actually contracts due to this loading M, bending moment M?
Right side.
Yeah, right side actually contracts, right? So bending moment will be positive or negative?
Negative.
Huh?
Negative, sir.
Yeah, negative. Okay, and similarly the front and back face. For example, if you are having a beam like this, okay, and you are loading along the horizontal direction, okay, in the horizontal plane you are actually applying some moment. Okay, so due to this, here what happens, actually the back surface actually contracts. Okay, so here the bending moment will be positive. Okay, so these are all the sign conventions with respect to shear force diagram and bending moment diagrams. Okay, so now let's proceed to the problems. So imagine first we will have a shaft like this. Okay, and to this shaft, like you are actually applying some tensile forces, which can be like T1, and you are applying at the bottom end T2. Okay, this is like a belt which is running the shaft, okay, or which is wrapped around the shaft. Okay, so here what you can say, T1 is greater than T2, right, for belt drive.
Yes,
It is,
sir.
yeah. So this is of radius r. Okay, so what I can do, the same system I can replace it by, for example, you consider this shaft as fixed at this end. Okay, so the same system I can replace it with the at this point I can actually give a load, and I can give a couple, right? So can you say what will be the load at this point if I am replacing this T1 and T2 by an equivalent load and equivalent bending couple?
T1 plus T2.
Yeah, it will be T1 plus T2. And what will be the couple at this point? In this plane of cross section, what will be the couple? Whether it is parallel to the plane of cross section or perpendicular to the plane of cross section.
Perpendicular.
Parallel.
Yeah, it's parallel actually. It's because like I have loaded it. Maybe my diagram might not be clear. Like it has been loaded like this. Okay. Yeah, like this it has been loaded. Okay.
Okay.
Yeah. So due to this, what couple I will get? Whether I will get a bending couple or twisting couple at the
Twist.
horizontal axis, around the horizontal axis.
Twisting.
Yeah,
Twisting.
twisting. So what will be the magnitude of this twisting couple?
T1 minus T2 into R.
Yeah, T1 minus T2 into R. Since like T1 into R will be along this direction. Yeah, T2 into R will be along this direction. So the effective, since I have said T1 is greater than T2, it will be like this, T1 minus T2 into R. Okay. So if I want to give the sign convention for twisting moment or twisting couple also, for example, you have to here use a right hand thumb rule. Okay. uh, take your right hand and like twist it around the direction of the twisting moment. Okay, and in which direction the thumb is pointing, that will be the twisting moment direction. You are getting it? You are getting what I'm saying, right? For example, the sign convention for twisting moment will be right hand. Using right hand thumb rule, we can actually get the direction of the twisting moment. For example, if you are moving the if you are rotating your your right hand along the twisting couple direction, the thumb, in which direction it will be pointing out in this example, whether it will be towards this or whether it will be towards this. Whether it
Inside.
will be, yeah, it will be inside. Yeah, so I can replace the same system as like it is having a shear force which is T1 plus T2. Okay, this is not an axial load, this is a shear load. Okay, and due to this inside, like for example, I will give double arrows for twisting moment. Okay, twisting couple, because we are having compressive axial load also similar to this, so I will give a double arrow. Okay, so this twisting moment which will be equal to T1 minus T2 into R. Okay, so for twisting moment, the sign convention is whenever it is acting away from the cross section. Okay, for example, if this is the cross section, whenever it is acting away from the cross section, then we will take it as a negative twisting couple. Okay, and whenever it is acting towards the cross section, we will consider it as a positive value.
Clockwise.
Yeah, see, clockwise, anti-clockwise, it actually depends on from which direction you are actually seeing, whether you are seeing from the right hand side or towards the left hand side, but mostly we will be seeing from the right hand side. Okay, so to avoid the confusion of that, like I have said, right, using the right hand thumb rule, when you are actually finding out the direction of thumb, then based on the direction of thumb, you can actually say whether it is pointing towards the cross section or whether it is pointing away from the cross section. For example, in our example, what the twisting couple is towards the cross section, right? So it will be a positive twisting moment. Okay.
Yes.
Yeah. So, and I said like this end is actually fixed, right? So can you think of like any reactions which is developed due to this? Will there be any reaction due to this shear load T1 plus T2 as well as this twisting moment? Because I have said like this end is fixed.
Shear stress.
Yeah.
Moment and
Huh? Can you repeat it once?
moment will be generated, no sir.
Yeah, moment will be generated. So which moment will be generated? Bending moment will be generated or twisting moment will be generated?
Twisting moment.
Yeah,
Both,
twisting moment will be
both, sir.
generated. Yeah,
In the opposite direction.
yeah, in the opposite direction. So this, yeah, someone was about to ask some doubt. And also, will there be any bending moment will be generated due to, for example, here I'm having an axial, I mean, shear load, right? T1 plus T2. Due to this, any shear load, shear reaction which will be developed at this end?
Yes, sir.
Yeah. So it will be like this, right? Opposite to the direction. Yeah.
Yes, sir.
Yes. And for imagine you let us take this length as L. Okay. Do you see any bending moment being generated or at a point? For example, let's take this is A and this is B. Whether you consider whether any bending moment will be generated at point A, and if so, due to which?
Due to T1 plus T2.
Yeah, due to T1 plus T2, you will be having a bending moment reaction. Okay, and the direction will be like this. Okay, I am naming it as MA, which will be equal to MA will be equal to what? T1 plus
P1
T2,
into L.
yeah, into L. Okay, so if I want to draw the axial load diagram, the shear force diagram, and the bending moment diagram or the twisting moment diagram for this A to B, can I draw? For example, what will be the axial load diagram for this if I consider this as point A and this as point B? It will be nothing, right? For example, it will be 0 at both the ends. Yeah?
Yes, sir.
Yeah. So, and if I draw the shear force diagram,
It will be a
imagine,
rectangle.
yeah, it will be a rectangle. So, whether it should be positive or it should be negative. So, when you are seeing from the top, okay, when you are seeing the T1 plus T2 from the top, in which direction the shear force is actually constituting a couple, whether it is in the clockwise direction or it is in the anti-clockwise direction.
Anti-clockwise.
So it should be positive or negative.
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 Yeah, and the magnitude of that will be, or the length breadth of this rectangle will be T1 plus T2. Yeah, so it will be a negative, and the magnitude of this will be T1 plus T2 at both the ends. Okay, so now coming to the bending moment diagram for this structure. Okay, so what will be the bending moment diagram for this structure A to B?
Triangle.
Yeah, it will be a triangle. So here at this point, so if I draw a triangle, so whether I should draw a triangle at this, for example, at B, what will be the bending moment value? It will be 0, right? So only it is a triangle, huh? Because I am not having a concentrated bending moment here. Whereas here I am having a concentrated bending moment which is equals to MA, or which is equals to T1 plus T2 into L, right?
Yes.
Yeah, so what will be the direction of, I mean, what will be the sign of this MA? Whether it should be, for example,
Positive.
positive. Why it is positive? For example, I could have drawn the diagram like this, right? Why I'm drawing this diagram like this? Here the magnitude will be T1 plus T2 into L. Yeah, why
Yeah,
I'm
left
drawing
hand
it as
side
a
clockwise, sir.
If you look from top, then backward fiber will be in
yes,
contraction.
yes. So if we look from the top, or if you look from the like front also. So for example, for this particular loading, the back surface will actually be contracted. Okay, so for example, this view I am drawing it from the top. So this back surface, this is the back surface. Okay, so this back surface will be contracted. So only I am drawing this as a positive bending moment. Okay, and due to this T1 plus T2 into L, this actually gets reduced to 0 and it follows a straight line. Okay, these things I will be explaining when we are going for like the shear force diagrams and bending moment diagrams for beams. Okay,
Sir,
till now we are in basics. Yeah.
sir, I didn't got what do you mean by the contract? I mean, where will it contract?
Okay, see, for example, when you are can you get the loading actually?
Yes, sir.
How this has been loaded, because you are having a
Yes, sir.
horizontal shear force diagram, right? For
Uh-huh.
example,
Uh-huh.
in the horizontal plane, I'm having a shear force diagram which is away from this screen, or which is into the screen. This T1 plus T2 is into the screen. Okay, so due to this, what happens? You will get a bending moment of MA, which is like it is like a reaction due to this fixed support. Okay. So due to this loading, what happens? This whole beam actually contracts towards the back surface. Can you imagine that?
Yes, sir. Yes, sir. Now
So when I'm looking from the top side, for example, this diagram is drawn in the horizontal plane.
now I got it, sir. Okay.
Yeah.
Thank you,
So
sir.
due to this, back surface will get contracted and front surface will get elongated. So based on sign convention which we have followed for bending moment diagrams, the top layer or the back surface or the left surface, when it gets contracted, we will have a positive bending moment. Okay. Yeah.
Excuse me, sir.
Yes.
So can you please explain the loading part? So because my network is having issue, like just the
Oh,
loading part, how it is.
okay, see, for example, imagine this as a belt drive, okay, which is actually moving the or turning this pulley, or shaft, okay, which is actually turning this shaft. Okay, so by belt drives we actually know T1 will be greater than T2, right? And I have attached one end of this shaft. Okay, so what will happen is, like, when I actually transfer this forces T1 and T2 to this longitudinal axis or the centroidal axis, how I will transfer? I will actually transfer this T1 to this side, and I will have a equivalent bending or the twisting couple T1 into R. Okay, and to this T2, I will again have an equivalent twisting couple which is equals to T2 into R. So my diagram T1 plus T2 will be along this. Okay, and I will have a T1 into R from this direction, and I will have T2 into R from this direction. So the net effect will be T1 minus T2 into R along this direction, since T1 is greater than T2.
So T1 minus T2 is the net torsional
Yeah,
moment.
net torsion, yes, net twisting couple or net torsion. You are getting it right?
Yes, sir, yes, yes.
Yeah, so based on that, I am actually finding out the reactions at the fixed end. Okay, due to this shear load, I will be getting a shear reaction at point A, okay, or at the cross section A. And due to this twisting couple T1 minus T2 into R, I will be getting a twisting reaction or a torsion reaction at the point A, as well as due to this shear load at point B, I will be getting a bending moment, which is will be equal to T1 plus T2 into L at point A.
Yes.
Yeah, so based on this, I have drawn the axial load diagram, shear force diagram, the bending moment diagram, as well as the twisting moment diagram. So what will be
Since
the,
both T1 and T2 are in the same direction, we have put T1 plus T2 also.
yeah, since both T1 and T2 are in same direction, we have written T1 plus T2.
Yes.
Okay, only, but when it comes to the direction of twisting moment, since both are opposite in directions, so we have to take care of this by taking T1 minus T2 into R.
Got it.
Yeah. So what will be the twisting moment diagram? Whether it will be, we have discussed, right? Here it is a positive twisting moment, okay? Since it is pointing towards the cross section. And the magnitude of this will be T1 plus, or oh sorry, T1 minus T2 into R. And it will be positive. So is there any doubts regarding this problem? No doubt, right? Shall we proceed to the next problem?
Yes,
Can I
sir.
proceed to the
Yes,
next
sir.
problem?
Yes,
Yeah,
sir.
Yes, sir.
yeah. So for the next problem, you have to determine the axial load, the shear force, the bending moment, and the twisting moment for this member. Okay. For example, I have a member like this. Okay. This is point B, point C, and point A. Okay. So this is of length L by 2, and this is of length L. And this is of force P. What is meant by this force? Actually, for example, if I am denoting a force like this, means it is pointing towards you, okay? And if I'm having a force like this, it is pointing away, towards the screen or into the screen, okay? So yeah, so based on this P, can you say in which direction this force is actually towards? It is
That would be
towards, yeah,
positive, sir.
no, let's come to the positive and negative direction later, but I'm saying, like, if I denote a force like this, means then you have a force which is actually towards
Entering,
this,
like.
yeah, entering like this, okay,
Okay.
yeah, okay. So for example, you have to determine the axial load, the shear force, the bending moment diagram, and the twisting moment diagram at point A, B, and C. Okay. So first I will draw the bending moment. First I will isolate the member B and C. Okay. And you are having a force P which is actually towards it or into the screen like this. Okay. So can you think of any reactions? What will be the reactions developed at point B?
Sir, will it be twisting, sir? Twisting.
Shear force and
Moment.
bending.
No. Yeah, shear force will be developed and bending moment will be developed. Okay. And this length is L by 2. For example, due to this, because these are interconnected members, right? Okay, these are interconnected members. So due to this, you will have a shear force which is developed due to this P, because for example, this BC member is in equilibrium. Okay, based on this only I'm doing all these things. Okay. So in order to
Oh,
maintain the equilibrium, I have to have a shear force, reaction shear force at point B. Then I have to have a bending moment at point B, which will be in this direction. Magnitude will be P into L by 2. Okay.
okay, sir.
Yeah. So from this you can draw the shear force diagram, the bending moment diagram, the twisting moment diagram, everything, right? For this member BC. Okay. For example, the axial load will be like 0, and whereas the shear force, what will be the shear force diagram?
Will it be rectangle with negative value?
Yeah, it will be a rectangle with a negative value. Okay. Because the couple formed due to this shear force P will be in anti-clockwise direction when viewed from the top. Okay.
So this
It is,
bending moment is in horizontal plane, isn't it?
yeah, can you repeat the question?
The bending moment is in horizontal plane.
Yeah, bending moment is in horizontal plane. Yes.
Okay, sir.
Yeah. And can you draw the bending moment diagram for this? Will it look like a triangle, right? It will look like a triangle, right?
Yes,
Yes,
sir.
Yes, sir.
positive.
Yeah. And it is positive or negative?
Positive.
Positive.
Yes. Because
Backward in contraction.
yeah, back surface is in gets contracted. Okay. So what will be the value of this bending moment at point A? It will be PL by 2. And bending, sorry, this will be B and C. And bending moment at point C will be 0 since you don't have any concentrated bending moments. Got it?
Yes, sir.
Yeah.
Yes, sir.
So now coming to member AB. Okay. So when you are coming to member AB, this force P should actually be inverted in direction. Okay. Okay.
Uh,
For, for example, P acts like this. So in order to have equilibrium at this point, so you will be having for member AB, the P will be acting along this direction. Okay. Is it fine?
yes, sir.
Yeah. And due to this bending moment PL by 2 at point B, what will be this PL by 2 for this member AB, whether it will be a bending moment or twisting moment?
Twisting.
Yeah, it will be a twisting moment because this PL by 2 is in horizontal plane, right? This is the horizontal plane. So in this PL by 2 is like this. So it will be a twisting couple for the member AB. Okay. And again the direction should be inverted. For example, if it is like this means then you have to invert the direction. So it will be something like this. Okay. TB equal to P into L by 2. Okay. Is the direction clear? And why you are actually getting twisting moment, that is also clear, right? Or should I have to explain it again? Shall I proceed further?
Yes, sir.
Yeah. So at point A, what are the reactions you will be getting since it is a fixed support? You will be getting a twisting moment, right? Which is equal and opposite to PL by 2.
Yes, sir.
Yeah. So this will be TA equal to P into L by 2. And you will be getting a shear force also, right? Which will be opposite to the force at point B. Okay. And then will there be any moment?
Yes, sir.
Yes, sir. P into
Yeah,
L.
P into L. Yes.
PTM.
Yes. Though, and in which plane it will be visible? This P into L bending moment. In which plane it actually acts?
Into the plane.
Yeah, it is like for example a right side plane. Okay. For example, perpendicular to this horizontal plane. Okay. In this plane it will act. Okay. M A equal to P into L. So can you draw the shear force diagram, the bending moment diagram, the twisting moment diagram for this member A, right? Okay. Yeah, what will be the shear force, whether it will be positive or negative?
So can you explain how the twist is coming?
Twisting moment, how it is coming.
Yes, sir.
Okay. See, actually, due to this force P, you are actually getting a bending moment at point B, right? When you are considering only member BC alone. Okay, when you are actually considering only member BC alone, you are actually having a bending moment at along this horizontal plane, P into L by 2. Okay, so this is point B, and this is the member BC. Okay,
Yes, sir.
and like this point B is connected to this member A. Okay, so for example, if see for BC it is a bending couple. Okay, since the loading is perpendicular to this cross section, whereas for this twisting moment, I mean for this member AB, it will be a twisting moment. Okay,
Okay, sir.
yeah.
So
So getting it right?
there will be both bending and the twisting moment by the BC member.
No, no, no. See, for BC member alone, you are having only bending moment, okay, and the shear force. Whereas for member AB, this bending moment PL by 2 will be a twisting moment for member AB.
Okay, so the twisting moment, the bending moment of BC member is uh, acting as a twisting moment for
Yes,
BA.
yes. Bending moment for member BC is acting as a twisting moment for member AB.
So also there will be bending moment for BA.
Yeah, bending moment for BA due to this because this is fixed,
Okay.
right? And also you are having a force P.
Okay. Sir. Yes.
So due to this shear force P, you will get a bending moment at this fixed support A.
Okay, sir.
Yes. So can you draw the shear force diagram for member AB? So this is member AB, and whether it will be positive or negative.
Is it positive rectangle?
Yes, it is a positive rectangle since it forms a couple in the clockwise direction. Okay, when you are viewing it from the right hand side. Okay, and its magnitude will be equal to P. And what will be the bending moment diagram? Where can I do? Yeah, I will draw it here. Bending moment diagram for member AB. Okay, whether it will be positive or negative.
Positive.
Positive. Why?
Backward in contraction.
Contraction.
Yeah, back surface gets contracted, so it will be positive. And it will be a triangle like this. Okay, and this magnitude will be P into L. And if you draw the twisting moment diagram, whether it will be positive or negative.
Negative.
Yeah, can
Positive.
anyone? Positive
Negative.
or
It's
Negative.
inside.
negative? Negative or
Negative.
yeah, negative. It is actually negative.
No,
Why it is negative?
because that would
Away from the
that like in a
Away from
concave lens.
yeah yeah it is actually when you are moving your right and when the thumb is actually pointing away from the cross section, so it will be a negative value.
Yes.
Yeah, this is B, this is A, and it is a negative value, and the magnitude will be PL by 2. Okay, up to this everything is clear.
Yes.
So the bending moment sign convention here, it's a bit confusing.
Okay, see, actually, bending moments sign convention. Actually, you can follow this sign convention TBL. Okay, T for top layer, B for bottom layer, and L for left side or back surface. I mean, sorry, T for top surface, B for back surface, and L for left side surface. Okay, so if all these things gets contracted, then the bending moment will be positive. Okay, so for example here due to this loading, okay, due to this shear force, you are actually getting a bending moment in the right hand. For example, this will be visible when you are actually seeing from this right side, right hand plane, right? Sorry, I couldn't able to draw it clearly, or since if it's an online class, then I can show you like physically. So you are getting it right. This will be actually in the right hand side plane, or a plane which is perpendicular to the horizontal plane.
Yes, sir. Yes, sir.
Yeah, so this is the horizontal plane. So you can imagine a plane which is perpendicular to this horizontal plane. Okay, in this, the bending moment is actually acting. So what happens due to this bending moment? And this bending moment is actually making the back surface or the back surface fiber to get contracted, whereas the fiber which is actually facing towards you, which is termed as the front surface, will actually get elongated. Okay, so if I'm drawing the fiber in right hand plane, okay, it will be something uh, like this. Okay, this I am terming it as the back surface, and this I am terming it as the front surface. Okay, so you are viewing this from this side, and due to this bending couple, this has twisted like this. I mean, it has the whole member AB has bent like this. You are getting it right, what I'm saying?
Yes, sir.
Okay. So please work out some problems based on this. Maybe we can work out some more problems based on this so that everything gets cleared. Okay. So let's go to maybe we can do a problem based on right surface gets contracted, okay, or elongated. For example, I'm having a member like this. Okay, this is A, this is B, this is C, and this is D. Okay, and here it is fixed. So can you for this structural member, can you determine the axial load, the shear force, the bending moment, and the twisting moment for the individual members? For example, the loading is like this. This is P and this is 2P, and this is A, this is A, and this is of length maybe L. Sorry, this also can be taken as A. Okay, so can you draw the for example, if I isolate this member ABC, okay, what will be the reaction at due to this loading at point B?
Shear and bending.
So will it 3
Yeah,
P?
shear. Yeah, it will be shear and bending moment. Okay, shear force of magnitude 3P.
3P, sir.
Yeah, bending moment reaction will be, for example, this is A, this is A, so you will be having a bending moment P into A towards this, you will be having a bending moment P into A towards this, so the reaction will be like this, MB equal to P into A. Correct?
Yes, sir.
Yeah. So, and again, if I draw the for example, let us complete the shear force diagram for this member ABC. Okay, so what will be the shear force diagram if I draw for member ABC? I mean, sorry, ABC. Yeah, this force acting P, whether it is positive or negative?
Negative, sir.
Yeah, negative. Am I going very slow, or like I have to proceed at this pace, or like I have to
That's fine, sir. That's fine, sir.
okay, I'm thinking like I'm proceeding very slowly. So this will be negative and the magnitude will be P. So at point B, can you imagine what will be the shear force 3P and whether it is positive or negative? For example, if I'm considering a section here,
Positive, sir.
yeah, it will be positive. And this will be 2P. Okay. And the total length of this will be 3P. Okay. And this will be positive. So this will be the shear force diagram for member BC. Okay. So can you say what will be the bending moment diagram, how it will look like for member ABC? At A, whether is there any bending moment at A?
No.
Yeah. So it will be 0, right?
Yes, sir.
Okay. So for at B, what will be the bending moment? For example, what will be the variation of bending moment from A to B? Whether it will be linear variation, it will be a linear variation. Like see, for example, if I take a section here and if I have for example, see, you can take a section here at a distance of x, and if you calculate the bending moment, it will be like P into x, right? Yeah.
Yes, sir.
Yeah, and it will be like positive or negative?
Negative, sir.
Pos-
Seems like.
Negative or positive? And if so, why?
Negative is hogging.
Yeah, can you say instead of like hogging, like I have said, right, another sign convention, like left hand side clockwise direction, left clockwise
Left
and
hand
right,
side clockwise positive.
yeah, left clockwise, right anti-clockwise. So here you could see it is like in the left hand side it is in the clockwise anti-clockwise direction, right?
Anti-clockwise, yeah.
Yeah, so it will be a negative value up
Negative.
to, yeah. So what will be the magnitude of this at this point? It will be P into A. Yeah.
So we can also say that since from viewing from the front, it is top surface is expanding, does it?
Viewing from the fringe surface. Yeah, that also we can say, but mostly I will be following this sign convention. Like for example, this is the sign convention I will be following for beams or something like that. Okay, so I'm actually very much convenient saying like left clockwise and right anti-clockwise, and sometimes like this TBL actually comes into picture. Okay, since here I couldn't explicitly see in which direction like it is actually turning this, so I am actually using this left clockwise and right anti-clockwise. Is it fine?
Yes.
Yeah. So at point B, I am having a concentrated bending moment P into A. Yeah. So, and that is also a negative direction. Okay. So this will be the total magnitude will be 2PA. I'm here writing the total magnitude. Okay. And from here you will be getting a linear variation. So this is point B, this is point C. Okay. This whole thing is in negative. So whether this is clear or should I have to explain it again?
No, sir, it's clear.
Okay. So now let's come to the member BD. Okay. So this 3P will act as a shear load, or how it will act for member BD? First, you need to invert the direction of this load 3P. Okay. So 3P will be acting something like this. Correct? What I have drawn is correct or not?
Yes, sir.
Okay. Sir, I haven't got it.
See, for example, 3P for member ABC, it is acting in the upward direction. So for member BD, you have to invert the sign and you have to put it. Okay. See, for example, this is 2P and this is P, right? So
Okay, sir.
yeah, 3P will be like this, right? Yeah, for member BD alone. Okay. Since I
The
have
BD
considered
alone, yeah.
since I have considered ABC as a separate member, 3P will be
Separate.
in the upward direction. For BD, it will be
Upward.
in the downward direction. Okay.
Now I got it. Okay.
Okay.
Thank you, sir.
Sir,
Yeah.
for a member ABC,
Yeah.
since we have a final output is like negative, we are giving a positive. I'm sorry, the moment which we are giving at B, the reaction moment.
You are talking about this PA value.
Yes.
Yeah. PA.
So that is due to generally the reaction would be opposite of the net moment.
Yes, opposite to the net moment. Yeah, since the net moment is towards this PA towards this, so I am giving a net moment in the opposite direction.
Okay.
That is for member ABC alone. Okay. Yeah.
Yes.
Okay. So if I'm taking this member BD, what will happen? I have to invert this moment. Okay. For example, this is acting towards this, so I will be taking opposite direction. Okay. P into A.
Yes.
No doubts, right? Up to this. Okay.
No.
Yeah. So what will be the reaction at point D? You will be having a loading like this. And actually, what is this 3P? Whether it's a shear load?
Axial load.
Yeah, it is an axial load, axial compressive load. Okay. And what about this PA? Due to this PA, you will be getting moment reaction at this D, right? Opposite to this. For example, if this is towards this, then I will be getting PA. And whether this PA is a bending moment for BD or a twisting moment for BD?
Bending. Is it bending?
Yeah, it will be a bending moment. Since like due to this loading PA, it will be like uh, deforming like this, right? For example, when you see this in profile plane again, like for example in the right surface, right hand side plane. Okay. No, actually, see, I have done one mistake. I think so.
Reaction will be in opposite.
Yeah, reaction will be in the opposite direction. So it will be no reaction. I have drawn the same thing. So if I extend it further, like for example, it will be like this. Okay, so this will be, I have drawn the reaction here wrongly. So it will be like this, P into A. So this will be a bending moment. Okay, so here, can you say in which plane this PA actually acting? Whether it is in the right hand side plane or it is in some other plane. From which plane this PA is actually visible? This is wrong.
Front.
What I have told is wrong.
Front.
Front, yeah, in the front plane only this PA will be visible, right? So again I will draw this thing. Okay, 3P acts like this, which is an axial compressive load, and this PA is actually acting like this. Since PA is like this, so here I am giving an opposite direction. So PA will be visible in the front plane. Okay, front plane, it is actually visible. I mean PA, and this will be PA. Okay, and this will be a bending moment for member BD. Okay, and whether this is a positive bending moment or negative bending moment, and based on what you will say this will be positive or negative. In the front plane you have said like PA is acting, right? So based on this, what you can say, which surface or which side actually gets contracted?
That
Left.
would that
Left in tension. Sorry, right in contraction. So
Yeah, right side actually is contracted, left side gets elongated. So bending moment is actually negative. Okay, For example, if I draw the bending moment diagram for member BD, okay, I have to draw a negative bending moment which is equals to PA, since right side surface gets contracted. Is it clear?
So it will be a triangle.
What? No, it won't be a triangle, because see, for example, here also I am having a value of a bending value of bending moment value of PA. Here also I am having a bending moment value of P into A. So it will be like a rectangle, like it will be a pure bending moment. Okay.
Okay, sir.
Yeah. Since in the previous example here and all, we have seen like here is no bending moment at this end, right? At one of the ends, at both these ends, bending moment value is 0. So you are getting a triangle formation like this, or a triangular diagram like this. But here at both the ends, you are actually having a bending moment, so you will be getting a rectangle like this. Clear, right?
So we did take the 3p in reverse direction for BD. So
Yes.
do we need to the if you transfer the bending moment of due to PA, do we need to take it in a reverse direction like that for
Yes,
BD?
see, for both bending moment or for all the loadings, like you need to take reverse direction for BD member compared to this ABC member. Okay, for example, here 3P is towards the upward direction, so here I have taken in the downward direction. And also here you could see the bending moment when you are seeing from the front, it will be in the anti-clockwise direction. So here I have taken in the clockwise direction for BD.
Okay. Sir.
Okay. So, for example, for member BD, the shear force will be, whether is there any shear force?
No,
No.
sir.
Yeah, it will be 0 for BD. So, axial loading
Because there's
diagram,
no transverse force, no, sir.
yeah, axial load we will be having. Okay.
Yes.
Yeah, axial load for member BD will be 3P, and it will also be negative because it is a compressive load. Okay. Up to this, it is clear, right?
Yes,
Okay.
sir.
So I will be giving you some homework problems based on this. Okay, I will upload all the homework problems by tomorrow. Okay, in the Google
Oh,
Drive. Okay, so you
oh,
can actually download that. Okay,
okay, sir. Okay,
yeah,
sir. Thank you.
and also like last week's homework problem I have given you, right? And if you download, I think the diagrams would be visible.
Yes, sir.
Yeah, I
After
have
downloading, it
renamed.
is visible.
Yeah.
After downloading, it is visible.
Yes, yes, yes. Yeah, I have renamed the file name also. So if you have downloaded, like all the diagrams would be visible. So based on this, I will be giving you some homework problems. Okay. So now we
Sir,
will
I can't
be.
gradient, but how can we access that assignments and
Yeah, I have copied the link to the chat box.
Okay, sir.
Yeah, I have copied the link to the chat box. So maybe at the end of the class again, I will copy the link to the chat box so that you can access it. Okay. I think it is accessible, right? You can watch the videos and you can also download the homework problems also.
Yes, sir. It is accessible.
Yeah. Okay. Fine.
So for the previous question, there was a 2p on the right side and p on the left side, isn't it? So
Yes.
why do you take that moment as p into a?
You are asking about this value, or you are speaking about this shear force diagram?
I mean, a moment at b.
Okay, see, moment at B, what actually happens is like, for example, if you take, see, due to this shear force P, you will be having a bending moment which will be equal to P into A in the anti-clockwise direction, right? So only I have taken it as a linear variation. Okay, and I have marked this value as P into A at this point. Okay, and after that, since you having a concentrated bending moment, okay, which is equals to P into A, so you will have a step like this, okay, which whose magnitude will be equal to P into A. So the total bending moment at B will be 2 PA.
Okay, sir.
Okay, is it clear, or should you or you need much more clear explanation?
Sir, can you explain it again?
See, for example, maybe I will be doing it here. Okay, so this will be A, B, C. These things will be much more clearer when you actually do the what to say. You can actually find out the bending moment at any cross section based on what like relationships. Also, you can get. For example, this is P, right? So you are having a concentrated moment of P into A here, and you are actually having 2P here. Okay, so due to this value of P, you will be having for example, if I take a cross section like this, okay, this is a cross section, so I am taking this cross section at a distance X. Okay, so due to this P, what will happen if you have a bending moment at cross section XX? For example, if I write the bending moment at cross section XX, you will be getting P into X, right? And this will be a negative value, since in the left hand side I am having a anti-clockwise direction. Okay, the sign convention is like left hand side, it should be in clockwise direction, so that I will be having a positive bending moment. Whereas in the left hand side, I am having a anti-clockwise direction bending moment, so I am writing as minus P into X. Okay,
Okay, sir.
yeah. So if I write at X is equals to A, the bending moment at B will be equal to minus P into A.
Okay, sir.
Yeah, and if I take a cross section like this, and if I see for example at this point B, you are actually again having a concentrated bending moment P into A, so which will be at B, again this will be adding, so you are getting minus 2P into A.
Okay, sir.
Okay, now it's clear, right?
Yes, sir.
Yeah. So now based on this, we will be doing a last problem. Okay, after this we will shift to uniformly loaded things. Okay, something like that. Okay, this is A, this is of length L, this is B, this is of length L by 2, and this is also of length L by 4. Okay, and this is C, and this is D. Okay, and here you are having a load P. And what is this load P actually denotes? You are having a load towards the,
Outside.
yeah, towards the outside. So it is like this. Okay, so if I draw the first for this, I have to again draw the shear force diagram, bending moment diagram, and the twisting moment diagram for each of the members. Okay, so first I will take the member CD. So this is the loading. Okay, so what you will get at point C, you will get a shear force reaction. Okay, and you will get a bending moment. Okay, which will be like this, P into L by 4. What I have drawn is correct or not? And this bending moment, where it will be visible, in which plane it will be visible? Hello.
Top.
Yeah, from when viewing from the top, it will be visible in the horizontal plane. Okay, here you are actually having this bending moment PL by 4. Okay, so for this you can draw the bending moment diagram and shear force diagram, right?
Mhm.
Yeah.
Yes, sir.
Yeah. So I'm directly proceeding to member BC. Okay. To member BC, this PL by 4, whether uh, what moment is it actually creates for member BC, and I have to invert it also, right? I have to change the direction. Huh? For example, if it is acting like this, means I have to invert it towards this.
Control clock.
Yeah. PL
PL
by
by
4.
4.
Yeah. And also this P, I have to change the direction. P. Okay, so this PL by 4, whether what moment it creates, bending moment it creates or twisting moment it creates for member BC.
Twisting.
Twisting.
Yeah, it will be twisting moment. Okay, so due to this PL by 4, you will be getting an equal and opposite twisting moment at the B. Okay, for example, if it is like this means, so you will be getting an opposite twisting moment like this. T equal to P into L by 4. And due to this force P, you will be getting shear force like this, P. Okay, up to this it is clear, right? And is there any reaction you will be getting at a point B? Any other reaction you could think of at point B? Or is
Moment,
the,
moment,
huh?
Bending moment.
moment,
Yeah, bending moment, yes. Bending moment. And what will be the value of bending moment?
PL, PL by 2.
Yeah, it will be PL by 2. So this creates a bending moment like this. So opposite to this, it will be P into L by 2. Okay. So for this, you can draw the bending moment and shear force diagram and the twisting moment diagram, right? I'm not drawing all those things. Or should I need to draw the shear force diagram, bending moment diagram, and the twisting moment diagram for member BC?
So please to us.
Okay. So for the member BC, what will be the shear force diagram? Whether it will be positive or negative?
Negative, sir.
Are you
Positive,
sure?
sir.
Yeah,
Positive.
yeah, it will be positive. Because when you are viewing from the right side, this forms a couple in the clockwise direction. Okay?
Sir, seems like an anti-clockwise.
Yeah?
No, no, sir.
Okay. So maybe due to diagram, maybe you couldn't identify.
Sir, actually, I have a doubt in how to view these kind of structures. Like for example, viewing from the front is different, but with the
Okay.
member BC, when it is having some load like this, like how to view it?
Yeah, see, when BC is having a loading like this, the basic thing is like you have to view it from the right side, on the top side, and the front side. These three sides you can view. And based on this, you can get the shear force diagram sign convention. Okay?
Yes.
Yeah. For example, here I have viewed it from the top side, and here I have viewed it from the right hand side. Okay, so this will be the shear force diagram. And what will be the bending moment diagram for member BC? How it will look like, and whether it is positive or negative? And which surface actually gets contracted or elongated? Or maybe you can see in which plane is actually it's acting. Okay, for example, in the right side plane, okay, I'm having this member BC, and I'm having this loading bending moment like this. Okay, this is actually P. Okay, this is
Is it
member BC.
positive?
Negative.
Negative. Can you actually say which surface actually gets contracted? For example, when you this is like this member, right? So based on this loading, which surface actually gets contracted? The front surface or the right surface or the back surface? Obviously here it is not. I mean, which surface actually gets contracted here?
So when we view from the right, left side is getting contracted.
Yes, yeah. So when you are viewing from the front surface gets contracted. Okay, So it will be like a negative, right? See, when I'm viewing it from the front side, okay, here I can't view it from the right hand side, okay. This is like from the right hand side I'm viewing it for, but I have to view it from the front side, since BL is like this, and this front surface actually gets contracted. Okay, this is the front surface and this is the back surface. This front surface actually gets contracted due to bending moment at the profile plane or the right hand side plane. So the bending moment will be negative, okay.
Yes.
Yeah, and this will be PL by 2 and this will be negative. Okay, here see, actually what I'm doing here for contraction and all, I'm just viewing it from the screen itself, or looking at the diagram itself. I'm not looking it from the right side, or like as one of you pointed out, like for example, when I'm viewing it from the right side, actually the left surface gets contracted. Like that we should not see. Okay, actually when I'm viewing it from the front surface, or the front side, based on the loading, the front surface gets contracted. So due to this, the bending moment diagram will be negative. Is it clear or not? Or maybe you can look at the previous videos and you can just check out what is the difference between all those things. Okay, for example, here you can see I have said the right surface gets contracted, right? Based on when I'm viewing from the front, I have said like this. Is it clear or not?
Yes, sir. Sir, actually, one small help.
Yeah.
Can you please tell the sign convention like once briefly so that we won't get
Okay,
confused?
see, I will explain it to you very clearly. For example, this is the member. Okay, this is A and this is B. Let AB be a member. Okay, so when I'm loading it like this, for example, this is a bending moment. Okay, so when I'm loading it like this, when I'm viewing it from the front surface, which surface actually, when I'm viewing it from the front, which surface actually gets contracted?
Right sides.
Yeah, right side gets contracted. No, right side gets contracted.
Left, sir, on the left would be contracted side as the moment on the.
No, I'm loading it like this. So see here, similar to this. This is like loading it from this side, right? Like that only I have loaded here. So here right side gets contracted. Okay, so this side gets contracted. So what sign convention we are following? TBL, which means like top surface, the back side and the left side. So if all these gets contracted, the bending moment will be positive. Okay, so this is the sign convention for again, but in this example, what it turns out, the bending moment is like this. Yeah, it is like this, right?
Yes, sir.
Yeah,
Yes, sir.
imagine like you are having a pen towards you, and you are actually what to say, applying loads towards you. Okay, so the bending moment, due to this, what happens, the front surface gets contracted. You can imagine like that. Here front surface gets contracted. Is it clear or not, or you are still having doubts? Maybe I can explain it again.
Yes.
Yeah, since this is an online class, I can't able to show you physically. So see, you can actually imagine, for example, here I'm applying loads like this, like that, you can imagine. So you will get to know which surface gets actually contracted. Here I'm applying loads like this, so front surface gets contracted, like that, you can imagine. Is this clear? Okay.
Yes, sir.
Yeah. So now what, up to what we have completed? Twisting moment, I mean bending moment diagram we have completed. So twisting moment diagram for member BC, can anyone say what will be the twisting moment diagram for member BC?
Positive.
Positive.
Yeah, it will be positive. And magnitude will be,
PL by 4.
yeah, PL by 4. Okay. Now let's proceed to member AB. Now for member AB, where we have drawn, yeah, this is actually BC. Okay. So for member AB, what will be the all the loading at the point B should be varied, right? Okay. For example, uh, P will be acting in this direction, and twisting couple P into L by 2 will be the acting. For example, for B it is like this, right? For example, this is the horizontal plane. Okay. So P into L by 4 is acting like this, right? So here I have to change the direction, P into L by 4, and this acts in the horizontal plane. Okay. My diagram is clear or not?
Clear.
Yeah. And P into L by 2 will be, how it will be acting? It will be acting something like this, right?
Anti-clockwise.
Yeah, in the anti-clock. No, clockwise direction when you are viewing from the front. Or when you are viewing it from the right side, it will be in anti-clockwise direction.
Okay, sir.
Yeah. So this P into L by 2, what couple it generates? Whether it generates a bending couple or twisting couple?
So twisting.
Sir,
Yeah, yeah.
sir,
Yes. Yes.
sir, which one are you asking, sir?
P into L by 2. P into L by 2, it actually generates a twisting couple for member AB. Okay. And P into L by 4, it is actually acting in the horizontal plane. Okay. P into L by 4 is acting in the horizontal plane. P into L by 2 is acting in the right side plane.
Sir, but in opposite direction, no?
Yes, direction I have changed, right? For example, for member BC, it is like this direction. So for member AB, I have changed it to this direction. So that's what I have drawn here. Is it clear?
PL by 4 is causing bending moment, is it?
Yeah, PL by 4 is causing bending moment, which is in the horizontal plane. So
Yes.
that also I have changed the direction and I have drawn. Okay.
So
Okay.
PL by 2 is negative.
Yeah, see, PL by 2, when I'm using the thumb rule, yeah, it will be negative or positive?
No, no, actually it's towards the cross section.
It will be positive.
Positive.
Yes. So let's find out the reactions at point A. Okay, what will be the reactions at point A due to this shear load? I will be getting a shear force at P, and due to this bending moment PL by 4, I will be getting a bending reaction. And can due to this shear load also, I will be getting a reaction here, right? Yeah. See this at A. Okay, at A, what is happening at point A? Due to this force P, okay, I'm getting a, see, this will generate P into L. Okay, so due to this I have to have a reaction M is equals to P into L. Okay, whereas due to this bending couple P into L by 4, which is towards this direction, okay, I have to have a reaction like this PL by 4. So these two are in opposite directions, right? So the final bending moment will be 3P into L by 4, which is in this direction. So 3pl by 4. Understood how I got 3pl by 4 at point A as the bending moment reaction, or should I have to repeat it again?
Not understood, sir. 3P L by 4.
Okay, fine. See, this is the member AB, correct? Okay, so due to this shear load P, what I will be getting a bending moment reaction, right? So that bending moment reaction will be in this direction, whose magnitude will be equal to P into this length L. Okay, up to this you have understood, right?
Yes, sir.
Yeah. Again, yes, again due to this bending moment PL by 4, okay, I will be getting a reaction P into L by 4 in the opposite direction. So these two are opposite bending moment reactions. So the net bending moment reaction will be towards this direction because PL is greater than PL by 4. So when I subtract PL with PL by 4, you will be getting 3PL by 4.
This is negative.
I mean, I'm not coming to negative or positive, but I'm just saying it is towards this direction. Okay. For example, this
Okay,
direction,
sir.
yeah, you can view it from the horizontal plane. It will be something like this. 3PL by 4. When you are viewing it from the top side, okay, in the horizontal plane, it will be something like this. Are you getting or not? Like, this will be the structure member AB. Okay.
Means initial reaction was PL, and
Yes.
the from that
See,
we are subtracting that PL by 4 because it
yes.
was in opposite direction, and so
Yeah.
we have 3PL by 4.
Yeah, 3PL by 4. See, due to this shear load P, you will be getting a bending moment P into L. So due to this bending moment P into L, you will be getting a reaction P into L towards this direction. And due to this bending couple, which is P into L by 4, okay, you will be getting a bending moment reaction P into L by 4 in the opposite direction. So these are reactions due to two different loadings, due to this loading and due to this loading, okay. So the final net bending moment reaction will be, since these two are in opposite directions, this direction dominates because the magnitude is higher. So towards this direction, you will be getting PL minus PL by 4, which is 3PL by 4. Understood or not? Or should I have to again explain?
It's clear.
It's clear, right?
Yes, sir.
Yeah. Okay, fine. So again, at point A, again I will be getting a twisting couple in the opposite direction due to this twisting moment PL by 2. Okay, and since this is towards this direction, I will be having an opposite direction. Here I cannot draw very clearly. Maybe like right, this is towards the cross section. Okay, so when I draw the twisting moment diagram for member AB, it will be positive or negative. I mean, twisting moment diagram, whether it should be positive or negative for member AB.
Positive.
What is the sign convention I have told you for twisting moment? First,
Positive.
positive. Because here, what is the twisting load? P into L by 2 is the twisting moment, right? So it will be positive since it is pointing to, since your thumb, when you use your right hand thumb, it is pointing towards the cross section. Okay, so it will be positive. Okay. At B, you are seeing what will be the direction of, you are rotating your hand and you are seeing what will be the direction of the thumb, and it will be pointing towards this cross section. Okay. Is it clear or not?
Yes, sir.
Okay. And what will be the shear force diagram? Whether it will be positive or negative. And from which side you have to see. From the top side you will be seeing, and it forms a couple in the clockwise direction. So it should be positive or negative.
Positive.
Yeah. It will be positive, whose magnitude will be equal to P. Okay. And for bending moment diagram, how it will look like for member AB? Here comes the toughest part. For example, this is point A, this is point B. Okay, imagine this is point A, this is
The
point B.
rectangle.
Are you sure it is a rectangle?
Two
Oh,
triangles.
no.
Yeah, two. Yeah, it will be two triangles. How it will be two triangle? For example, here you can see, right, at a point A it will be 3pl/4. Yeah, and for example, if you are taking a cross section like this is like left.
The trapezium.
No, it won't be a trapezium, it will actually be a two triangles. Okay, this will be negative. Okay, which will be equal to 3pl/4. Since this is like for example, when I'm viewing it from the top side, okay, imagine when I'm viewing this member from the top side, this 3pl/4 is like left clockwise or anti-clockwise.
Anti-clockwise.
So it will be positive or negative.
Negative.
Yeah, so this will be negative. And when I'm viewing it from the for example, if you take the right side, okay, see this I have viewed it this I'm viewing it from the top. Okay, this is like 3pl/4 when I'm seeing at point A. For example, at point B also I'm having a concentrated bending moment value which is equals to pl/4. Okay, so and I am taking a same section like this. Okay, and I am viewing it from the top, and this pl/4 forms a moment in which direction, like right side, anti-clockwise or clockwise?
Clockwise.
Right side anti-clockwise.
Right side anti-clockwise. So it will be positive or negative?
Positive.
Positive.
Positive, yes. Whose magnitude will be equal to pl/4. So in this, you will be having a straight line like this. Okay. So if I want to draw very neatly, I can draw maybe here. Okay, I will show you here. This will be pl/4 and this will be 3pl/4. This is negative, this is positive. Clear, right? Up to this it is clear. Any doubts you have, you can clarify based on sign convention or something like that.
Sir, I have a doubt. Actually,
Yes.
while considering the net moment, we took it as PL minus PL/4, no, sir?
Yes.
So at that time, like we considered the moment due to the point load P, that is PL, and then PL/4, which is the concentrated moment. But
Yes.
while drawing, like we have drawn it separately, no, so like because
No.
like what I meant is like for
Mhm.
example, the
Yes.
PL/4 is the only moment which is due to the concentrated moment, no, sir. So we should have drawn it first separately, and then the moment due to this point load, which is a straight line.
No, I couldn't able to get you what you are saying. Maybe see, for example, here at point B, okay, this is PL/4, right? The concentrated bending moment at point B is actually PL/4. Agree or not?
Yes.
Yeah. So due to that, and also I have said like it is right anti-clockwise. So it is positive. Okay. And again I am coming to point A and I am seeing what is the net moment, which is actually 3pl/4 in the left clockwise left anti-clockwise direction. So I have drawn it in the negative side. So I am joining these two by a straight line, because here I am not having any, see here why I am drawing it as a straight line means there is a concept which I will come in the later classes. Okay, for example, here you could see the variation of the shear force diagram, right?
Yes,
The
sir.
yeah, here the shear force diagram is actually constant. The slope of this shear force diagram is actually constant, which means like it is a straight line. So for example, if the slope of shear force diagram, if it is a straight line, then I mean the slope of shear force is, if it is a constant, then the bending moment diagram should have a slope which should be of constant slope.
Yes.
So only I have drawn it as a straight line.
Yes, sir. Now I got it.
Yeah, now everything is clear. Is there any doubts?
No, sir, no.
Okay, so right now I'm stopping the class here. Okay, so in the upcoming classes we will be seeing about how I mean we will be seeing about beams subjected to uniformly distributed loads, then uniformly varying loads, and the concept of like how the variation of shear force diagram affects the variation of bending moment diagrams, everything like that. Okay,
Sir. Thank
and
you.
then and then we will be seeing about a bending stress, then we will see about a shear stress in beams, bending stress in beams, and then we will proceed to deflection of beams. Okay,
Okay, sir.
yeah,
Okay,
so
sir. Thank you, sir.
yeah,
Sir,
thank you. Yes,
can we have your mail ID so that if doubt come in solving question, then we can ask?
sure, I will give my mail ID in the chat box. Okay,
So your channel name?
channel name, actually I have created, but I have uploaded all those videos in the Google Drive itself, so you can uh, see the videos from the Google Drive also. Okay,
Okay.
yeah, I will share my mail ID. I have shared the mail ID with you.
Sir, can you share the drive link also?
Yeah, I will share the drive link also. So see to that whether the drive link is accessible. Okay,
Sir, for the previous homework problem,
yeah,
answer.
answers. Okay, I will put the answers also. Okay, I
Okay,
mean
sir.
only the final answer I will be putting it up there. Okay,
Yes, sir.
yeah.
Thank you, sir.
Hmm.
Thank you, sir.
Yeah, if everything is good, like whether you need to have any changes in my way of teaching also, you can share it with me. I'm going
Sir,
very slowly or very fast, or I have to do more problems,
No,
or what
sir.
is, yeah,
No, no, sir. That's fine.
okay,
No, no, sir. That's fine, sir.
sir,
okay, yes,
while uh, presenting on that screen, can you use that laser pen so that sometime it get missed where you are saying that?
oh, okay, then I will try to do that.
Okay, sir.